Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video demonstrates how to use the multiplication rule. Let's get started. Some key concepts we need to go over when talking about the multiplication rule. First, the basic multiplication rule is used for finding the probability of A and B occurring. Now, take note, the probability of A and B is not the probability of A plus B. The probability of A and B is the probability that event A occurs first in a first trial, and then in a second trial, B occurs later. So there's two trials involved with A and B. The probability of A plus B is the probability that event A and B occur together at the same time in the same trial. So it's important that we know the difference of this because the multiplication rule is used for finding events that occur in successive trials, not in the same trial. Now we also have to check for any dependency among our events, because if we have dependency among our events, then generally speaking, we have to adjust our calculation so that we get the right probability out. The dependency will actually change the way we calculate the probability a little bit, so we have to be on alert for any events that are dependent. We'll talk more about that in a moment. But first, let's talk about the multiplication rule itself. Again, I don't know why your textbook author does this, but he classifies there's two different multiplication rules for calculating probabilities. First, there's the formal multiplication rule, and it basically says that the probability of A and B is the probability of A times the probability of B given A. So the probability of A and B is the probability that event A occurs first in a first trial, and then event B occurs second in the next trial. The probability of B given A is the probability that event B occurs after A has already occurred. Then there's what we call the intuitive multiplication rule. And in this rule, we multiply the probability of event A by the probability of event B. We need to make sure that the probability of event B takes into account the previous occurrence of event A, so there's no double counting. And we always want to consider whether events are independent or dependent and adjust your calculations accordingly. Now, again, I don't know why your textbook author separates things out like this, because just as we saw with the addition rule, there's no real change in the operation that we're doing here. We're taking two events and multiplying them together. It's the same thing here. And this statement right here makes sure the probability of event B takes into account the previous occurrence of event A. That's this part right here. The probability of B given that A has already occurred. So I don't know why we're separating this out. It's really the same calculation. So don't worry about separating this out. Just learn how to apply the multiplication rule and you'll be okay. Let's talk for a moment about the dependency of events, because as I mentioned just a moment ago, whether or not your events are dependent will adjust the calculation for how you calculate your probability. So two events A and B are going to be independent if the occurrence of one does not affect the probability of the occurrence of the other. So if you're calculating the probability the same for each of these different events, then your events are going to be independent. Several events can be similarly independent if the occurrence of any does not affect the probability of the occurrence of the other. So if you're using the same numbers, that's what I mean by calculating the same. If you're using the same numbers to calculate your probability, then your events are typically independent. However, if one affects the other, then they're not going to be independent, they're going to be dependent. Two events are dependent if the occurrence of one affects the probability of the other. It doesn't mean that one causes the other, but it does mean that the way you affect the calculation is changed. To illustrate that concept, look over here at the marbles that we have. So suppose we have these 5 marbles here in a bag. So we've got 1 red and we've got 4 blue. Okay, so in the first trial, let's say we take out a marble, and we're going to sample without replacement, which means we don't put the marble back in after we take it out. So if we take a blue marble, then here on the second row, we end up with 3 marbles and 1 red marble. Now, before we took out the first marble, the probability of selecting a red marble is 1 out of 5. But because we didn't put the marble we took out back in, now we've got 3 blue marbles and 1 red marble. Now the probability of selecting the red marble is 1 in 4. That means these events are dependent because the way we calculate that probability has changed. Now instead of 1 out of 5, now it's 1 out of 4. And you can see that with successive drawing of the marbles, the probability of selecting the red marble will change. The probability of selecting the blue marbles also changes. Here we've got 4 out of 5, and then when we take out that first marble, now with what's left, the probability of selecting a blue marble is 3 out of 4. So we've gone down from 80% to 75%. And so it goes through each successive trial. So these events are what we would call dependent events because the numbers we're using to calculate the probabilities of the same thing keep changing with each trial. It doesn't mean that one event is causing the other. It just means the way we're calculating the probability is changing. We're using different numbers to change that. Let's look through an example here. So suppose we have 50 drug users testing for their drug with the following results. So 44 test positive, 6 test negative, so we've got 50 results total. If 2 of these 50 subjects are randomly selected without replacement, okay, without replacement means we don't put them back in the pool to be sampled again. So they're selected without replacement. Find the probability that the first person tested positive and the second person tested negative. So here's how this plays out. First, we're going to calculate the probability that the first person tests positive. So that's the part over the whole. So we got 44. That's the part that tests positive over the whole, which is 50. Then we're going to take the probability for the negative result for the second person. So that probability's got 6. There's 6 people that test negative. But now look at the whole. The whole is now 49. Why is the whole 49? Because we're selecting these people without replacement. So when you take that first person out of the pool, and he or she's not going to be selected again, now you no longer have 50 total. Now you've got 49 total. So you have to make that adjustment in your calculation. Now we've got these 2 respective probabilities. All we do now is multiply them together, and we get 0.108. So 10.8%, this is the probability that your first person tests positive, your second person tests negative when you're randomly selected without replacement. And that's all there is to it. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.